Today we'll start with a new chapter entitled Titrimetric Method for Analysis. So generally, this chapter we divided into 4 parts, which are part 1, part 2, part 3 and part 4. The COs involved in this chapter are CO1 and CO3, while the POs are PO1 and PO2. Before we go further, I would like you guys to have a look at this video to get some information about this chapter.
You should use a stock solution of a known concentration. The stock solution will be put into the burette. This is a burette. Notice how it is clamped, and there is a white piece of paper underneath it, so you can see where the end point is. This is how to correctly fill a burette. You may find it easier to take the burette off the clamp and hold it in front of you. You're filling at an angle to ensure there's no bubbles trapped inside. Be careful not to overfill the burette. Run the liquid level down until it is at a measurable value. You measure the value from the bottom of the meniscus. Measure out a precise volume of your unknown concentration solution and add an indicator. In this case, phenolphthalein is used. Now you perform a rough test run or rangefinder. This is roughly titrating the stock solution against your unknown solution sample. Ensure that you swirl the sample at all times. You'll know when the endpoint is reached from when the indicator changes, in this case, from pink to clear. As this is the rough run, accuracy is not such an issue. It is just a rough guide to how much is required. There the endpoint has been reached, and the flow has stopped, giving a rough value. Now you have a rough guide to how much volume is required. You will then do the actual titration, ensuring you swirl it at all times. When you get to within about 1 centimetre cubes of the rangefinder, slow down the flow rate from the burette. As you can see here, it's been slowed down to a drip. This makes your reading much more accurate, which is very important in this technique, since your final results must be within 0.1 mil of each other. This is known as concordant results.
Okay, I hope that you guys get something from the previous video. So from the previous video, you may hear the few terms such as endpoint, burette, indicator. Okay, so basically in this chapter there are few topics. So the first one, overview of titrimetry, followed by titration based on precipitation and acid-base reaction, and finally the application of titrimetric methods. So at the end of the chapter, you must be able to discuss the overview of titrimetry in terms of the equivalent point, end point, volume as a signal, titration curve, burette, as well as able to differentiate between acid-base reaction and precipitation reaction. So, what is titrimetric methods? So, titrimetric methods is a quantitative procedures based on measuring the amount of reagent of known concentration that is required to react completely with the analyte. So in the basic principle, to perform the titration, it must consist two main components, which are titrant and analyte. So the reaction of the titrant and analyte will produce a product. Okay, so there are few requirements for the titration, such as stoichiometry reaction, rapid rate reaction, quantitative reaction, and define the end or the equivalent point. So what does it mean by end and equivalent point? So equivalent point is related to the amount of reactant consumed, while the end point is related to the physical sign that associate with the condition of chemical equivalence. So in the simple word, equivalent point can get based on the stoichiometry reaction, whereas for the end point can see by the physical changes on the analyte. So to perform the titration, we must use a standard solutions. Standard solutions can be either in a primary or secondary standard. These are the properties of the primary standard. It must high purity, atmospheric stable, independent of humidity, modest cost, large molar mass, and non-hygroscopic. So generally, there are 4 types of titrimetry. However, in this chapter, we just focus on the first 2 types, which are precipitation and acid-base titration. So we'll start with the acid-base titration. Acid-base titration, also known as neutralization, where the acid is reacted with equivalent amount of base. Then we have to plot the titration curve. Titration curve consists of 2 components, which are independent variable. On the x-axis, it is the volume of the titrant, and the dependent variable on the y-axis, it is the p-value or the pH. And the equivalent point is the point at which all the starting solution has been neutralized by the titrant. So this is an example of the titration curve, where it consists of 2 axes, y-axis for the pH and the x-axis for the titrant. So these are the titration curve. So the straight line is the equivalent point. So end point and equivalent point is a signal that a reaction is complete. So how to determine the end point? The easiest way to determine the end point by using the indicator. For instance, for this particular reaction, so the analyte is base, so we use the phenol red as the indicator, and when we add the titrant to the base, then it reach the equivalent point, and the indicator turn to the pink color, and excessive of the titrant make the analyte become red. These are few examples of the common indicators that used for the acid-base titration. So the phenol red used for the previous slide. So these are the titration of our hypothetical unknown. So step by step. So the titration tips. So from these slides, we can see that it's very tedious to get the endpoint. So to improve the endpoint detection, now we use the pH meter. pH combination electrode. So how to do a pH titration? So to do a pH titration, we need combination electrode, pH meter, standard buffer solutions for reference, burette, and stirring mechanism. So the advantages of using this pH meter: no indicator needed, and exact point of the endpoint can be determined. Okay, so that's all for the first part. So see you in the next part. Bye!